Thanks for joining us this morning on this Steps to a Successful Cloud Adoption. I know when it was sent out in the WebEx invite, it might have said 5 steps, but we thought we'd put a few more in there, so I hope that's okay. For those of you who don't know me, I'm Andy, I'm the CTO of A&S. I look after solution architecture, research and development, and go-to-market here. I've been with the business for about 12 years now, and about 10 of those years I've been in the CTO role. So some people I know on the WebEx and some people I don't, so if I don't know you then thanks for joining and welcome. I hope more people haven't got snowed in this morning. It looks like the weather's taken a turn again, so I hope everyone managed to get safely where they are. I know you've had a few people this morning who have phoned and said that maybe they can't get in the office because of where they live, so I thought we were over that, but it looks like it's going to be set for a cold day again. But anyway, I hope you enjoy the next 45 minutes. If you've got a few questions, please pop them in the WebEx chat at the bottom. There should be a good 5 or 10 minutes at the end. If I can answer those, then great. If not, then I can take those away and direct them back at you. So the purpose of the WebEx this morning is really just to talk through some experiences of organisations that are helping adopt cloud, some of the challenges, and some sort of real-life info. I hope that's okay. I don't really want to talk about why you should or shouldn't adopt cloud or any of those sort of things that you see from many of the main vendors or the hyperscalers. I really want to just give you some practical tips and advice, and I've thrown a few myths in there as well of things that you should be wary of. You know, there's a lot of stuff out there on the internet, and there's a lot of stuff, you know, that people talk about at roundtables and various different forums that sometimes we believe that when we've actually done some of these migrations and cloud platforming for customers that are either not true or something that becomes insignificant. So I just want to share a few of those with you, and I hope that's okay. So a few motivators then. So what I wanted to talk about here is not why you should or adopt cloud. And when I talk about cloud on this webinar, I basically mean the hyperscalers such as Microsoft Azure and Amazon Web Services. I'm focusing particularly on those two hyperscale cloud platforms. But one of the first motivators that we see a lot, and anybody who knows A&S knows we've got an assessment process like a cloud adoption framework. That we did 28 of those for customers last year. And at the start of that cloud adoption framework is always the motivator. What is it that's driving the organisation to do something different? And that might not be cloud, it might be digital, it might be data center zero, whatever that might be, but there's usually an initiative that they're looking to lead with. There's always more than one, but what actual initiative is that they're looking to lead a piece of transformation with? And the first one is always some form of digital. We are building a new app, we are building a new BI platform, we are building a new system of engagement or system of innovation, and we're looking to effectively use cloud technology where possible in order to build out that new platform. So this might be nothing to do with the old, nothing to do with turning off data centers, nothing to do with rehosting. This could be a complete and utter, we're building some brand new applications. And machine learning as a prime example of one of those. You know, can we migrate the data from the current data warehouse into the new data warehouse, and can we start to take some you know, advantages of new technology? Well, not really new technology, but technology becoming mainstream now in cloud on a pay-per-use, as things like machine learning. Blockchain starting to come up actually, which is interesting. Just more so the last 6 months. Organisations now starting to look at exploiting blockchain. If you look at like Microsoft Azure, Amazon Web Services, you can build a full, you know, blockchain cluster in a hyperscale cloud, a private blockchain cluster really quite easily now. So from an infrastructure perspective, that's much easier than it was 2 years ago when we first started playing around with that. But we start to see, you know, some of these organisations starting to think about AI, ML. We still get the data center zero projects, which are interesting. So these are people coming out of the sort of the facilities game. So effectively, I'm looking to you know, turn off data centers and re-platform, completely come out of facilities. Maybe I've had a data center that was 15 years old. We're not going to get a new one. We're not going to refurb it. We're not touching the aircon. We're literally going to do everything we can to get all of this over the next 2, 3, 4 years into a hyperscale cloud and just go complete DC zero. There's been the shift as well to enhanced operational capability. So we have a lot of organisations that have got really operationally heavy IT teams, very small development and software functions, very operationally heavy, lots of traditional systems, lots of traditional processes and ways of doing things that we've been doing for 10, 20, 30 years in enterprise IT. And people are really looking to get much more efficient with the way that they run lean, you know, really adopting new ways of change control, continuous DevOps processes maybe, but actually starting to shift the team's focus away from operational day-to-day, and by removing some of that operational day-to-day on infrastructure and hardware and some of the maintenance and feeding and watering that's you know, that's effectively involved with that, how do we get much higher up the stack, and how do we get into much more applications, platforms, frameworks, and some of the next-gen cloud-native architectures that people are starting to look at. And the other one always comes up is cost. And that's the first one I want to talk through really, because everyone's got opinion on cost on public cloud. So the first thing is a tip, is don't presume anything really. And organisations, there's a lot of people out there that have not touched cloud, not done anything with it, don't know a lot about it, but have got a preconceived idea on it already from a dinner they've been to, or somebody that's had a bad experience, or somebody that claims it's not secure, or whatever that is. But I would first say go into it with an open mind, because you'd be surprised. I mean, I think I've got one of the best jobs in the world, and I get to be on the I'm on the M6 and the Pendolino every single day in the UK, and I get to meet so many different customers, and it's not so much now, but certainly over the last 2 years, many organisations who've not touched it, don't have a team in it, don't really know much about cloud native application architecture, or never done a business case, never done an analysis or a readiness assessment, presuming things before they start. And I would always just say go in with an open mind and don't presume anything. Don't presume it's more or less secure, don't presume it's better for you or worse for you, don't presume it's better operationally, don't presume it's cheaper or dearer. Go in with a really open mind and engage on a good assessment, which I'll talk about later, to just make sure that you engage with the right way, with a nice open mind. But I certainly wouldn't be presuming in the early instances. So the first myth really is that cloud is expensive. Now, there's a lot of people out there that have got traditional monolithic legacy systems that if you are basically doing like for like against cheap hardware into the cloud, yes, potentially that one system on its own could absolutely be dearer than maybe what it's being run on that hardware stack today. I don't dispute it, and we see quite a lot of that. Cloud really is in the total cost of ownership in total across the whole estate. So I want to talk about a simple application. I want to talk you through it just to give you a good idea of what we mean when we talk about establishing a baseline and just trying to get your head around some of the sort of myths and realities around cost. So let's take certainly the mindset first off. So before we go into the actual detail, let's take the mindset. A lot of organisations have got what we call virtual architects today. They might be virtual architects, might be infrastructure architects, whatever they may be, infrastructure operations, traditional I&O team. And if I sort of take 4 key pillars of what those people sort of focus on, if I take the virtual architect, they're always designing for stability. So if you kind of take a look at when you are buying a full hardware stack of equipment, you've got all this hardware racked and stacked in front of you, all cabled and integrated, ready to go. One of the first things that you do is try and de-risk that estate. If you've got an application that needs 1,000 IOPS, you might give it 2,000 IOPS. If you've got a piece of application that maybe requires 8 gig of RAM, you give it 16, whatever that may be, but you're always over-provisioning. There's a lot of over-provisioning in on-prem systems, and it's all usually about risk, more performance than it actually needs, more compute memory storage than maybe it actually needs. And that's one of the first sort of principles, and it's always a risk, and it's why we buy 2 of everything, and it's why we have, mean time between failure statistics, it's why we have grid and N+1 based regimes. I'll talk about in a sec, but it's very risk-based. Manages via system GUIs, so in any traditional system there'll be multiple GUIs, a backup. Even in the newer systems where you've got hyper-converged platforms where some of it is even down to 1 GUI, you've still got backup and archive, you've got networking, you've got all the associated, maybe anywhere between 6 and 10 different login points to provision something, and you would usually do that through some form of a GUI or, from a networking perspective, maybe through a CLI. Very virtual machine focused. How many VMs have we got? And it's all around VMs typically. And that's quite key. Because when we sort of move to cloud, VMs are a little bit less relevant. Actually, there's a reason why they're called instances, and when you actually come up into the higher into the stack, you start looking at application architecture. We don't really talk about VMs as much, but the economics, 36 to 60 month depreciation cycle, typically buy everything up front, and then usually because you over provision, you never really get the 5 years growth out of it. You're always buying again at 18 months, 24 months, 36 months. Install plus hardware from a procurement perspective, so someone's going to charge you maybe 100, 200,000 pounds to bolt it all together. You've got all your support, and then obviously you've got the procurement, the beauty parades of all the different hardwares and everything that you've got to do, maybe 5 or 6 vendors, and maybe you're baking off from a technical perspective. You've got your platform tooling, your traditional OpenView, SolarWinds, Microsoft System Center, vRealize operations, things that are embedded into your workflows and your operational systems. And then your DR, buy everything twice, snapshots at the SAN layer, or maybe some kind of software that does that. Everything's a recovery of the full stack. You sort of hit the panic button and DR and SRM kicks in, and you've got all these integration and adaptation points that basically boot everything up in a certain order, and you can test it all. And everything's very much at the infrastructure layer to do that. And that's sort of the sort of what we're dealing with in traditional IT departments and I&O departments today, that people have got a good knowledge over the last 10 years of performing in a virtualization role. And in New World Ops looks very different. And the reason why I want to talk about this a little bit really is because We have two teams at A&S that do this. We have the operational team that do, the slide that I've just been on, and then moving forward, we have a New World team. That doesn't mean that people can't move between the two, of course not. But it means there is a mindset difference when you move to cloud in terms of how operations should be undertaken. So ops in the cloud is very different. If you go into cloud with just using it as hosting, that's when it become quite expensive. So I'm moving the VM from on-prem into the cloud. And the VM just sits, and I'm basically using Microsoft Azure or Amazon Web Services Management Console as if it was vCenter. I'm not really changing anything operationally, all the processes stay the same. That VM lives in there and it sits there. But the only difference being now is the way I pay for it. I get a monthly bill for it or an hourly bill. I don't, buy it 5 years up front, potentially. So you kind of look in the New World operation. Well, the cloud architect also designs for efficiency, and that's a key point. Because if you lift and shift the virtual machine as it is today, and you just put that into a virtual machine architecture in the cloud without any form of optimization, and we see a lot of this, then yeah, it can be quite expensive, without a doubt. And a lot of our cloud check service identifies these inefficiencies, and every single one of our cloud check services identified anywhere between 20 and 60% savings in an infrastructure by optimizing on the way in. We see a lot of people who just literally buy some tooling, move the virtual machine in as is, and then go, wow, it's expensive. Yes, of course it is, because that's not how you do it. The cost model is completely different, and therefore the thought and the mindset changes. We try and manage everything with automation and scripts. So, there's a lot of things that you can do in cloud with function-based compute, with AWS Lambda and Microsoft Functions that effectively can give you some amazing ways of treating operations, because now you can start to script yourself around all sorts of really cool things that you couldn't really do before with traditional systems that have got set configuration templates. We can write a function for pretty much anything. That's the beauty of function-based compute. Particular backup routines, particular data dumps, whatever we need to do at any time, that's what we have functions for. And having that function-based compute that's bound into the hyperscaler platform gives us so much flexibility in operations. Everything's about platform and app, everything. Nothing's really about VMs. Or we try and get away from VMs where possible. There's lots of VMs in the cloud. I'm not suggesting in any way, shape or form that you can just take your app out of a VM. But we want to be trying to get higher up the stack if we physically can. And operations is always right-sizing capacity and performance. So to give you an example, when Microsoft or Amazon release a brand new instance that's effectively twice the memory for half the price, or twice the CPU for half the price, there's an operational process as fast as possible to change all those instances then right across our managed services team to make sure that the customers get the savings that, Moore's Law's given us in real time. You don't really get that with a piece of hardware you're writing off for 5 years. At the end of 5 years, that's one of the most inefficient things you can have in your data center. But when you get a brand new cloud instance that's half the price for twice the memory, twice the capacity, then yeah, we change that instantly. So you're getting instant benefits, and right sizing and optimization is such a big part of cloud. On our desk across all our customers, we're permanently right sizing all the time, and all those savings keep adding up. It's all the pennies that mount up into pounds, that mount up into thousands, by just permanently making sure, whether it's through the night or whatever, that we've got automation scripts running, that we're always right sizing. The VM is never really too good for the job. Which kind of brings you into monitoring, so you can predict peak loads and times, and you can have automation that kicks in beforehand. And that's how you sort of get to this lean operating model, which gives us now, the economics of touching on right sizing, but just in time provisioning, everything's tagged. You're now in a position where cost centers are tagged quite easily that we don't really get on-prem. So it sort of forces that. Everything, we have policies that mean everything has to be tagged. Everything has to have a cost center. Absolutely everything needs to be accounted for. We need to have an operational process against absolutely everything. So is that under high change rate? Is it under low change rate? Is the first operational thing to do ring a developer? Is it to ring operations? Is it to restart a service? But that tag gives us a full operational process in real time. So tagging is really quite key. And we do shut a lot of things down. It's not just test and dev. We shut production systems down for customers quite happily between maybe the hours of 12 and 6. It might only be 6 hours a day, but we will force a shutdown if we know full well that the usage pattern of that application, despite the fact that it's a production application, if it's certainly tier 2 or lower, we do actually shut that down, and over a year that'll save a mass amount of money if we know full well that usage pattern suits that. So we do that quite regular, and again, it's a different mindset change. You wouldn't usually do that on-prem. Your tooling's very different. We're seeing things now like Docker, so applications, and there's you can do some quite funky stuff, application modernization, by getting your traditional applications to run in a container to make them more leaner. You're using things like Chef Compliance Manager, Chef tooling to basically build your system, so you're getting good standardized repeatability. Cloud security is a little bit different. We use a lot of alert logic, which is really an amazing tool. It's like sock in a box, so it effectively outsources your security for a price per month, and it's a really, really good service. So very different to maybe what you're used to on your traditional security on-prem, but really fast, really agile, integrates with your development processes, integrates with your applications, all automated builds, so really nice modern security. And then in disaster recovery there, well, you never really have it just twice. You know, you'll have a secondary region, or maybe even in some cases a secondary cloud. You may be using chaos engines to test application resilience. You design with ephemeral instances, so if you lose the instance, you haven't got data on that instance, and you effectively automate the rebuild, but you get out of this sort of buying twice. You know, everything's just templates that can be booted up in any way, shape or form. You don't need to be now provisioning hardware and everything for disaster recovery, which takes time, cost and money. So if I go to a quick app example, 3-tier app. Really simple, straightforward. Web front end, 32 gig of RAM, app tier, 16 gig of RAM, database tier, 32 gig of RAM, 4 CPUs, 300 gig of data. Quite common, standard 3-tier application. Now, when you actually get into a customer, no, there's not many that actually look like this. They're all sort of mashed into other systems and got connections here, there, and everywhere. And, you know, I kind of sometimes say to people, what is a 3-tier app these days? But just to use it as an example, here we go. So, we do use a Gartner framework to do chargeback and showback. There's two different methods that Gartner promote for this, depending on how you want to account for certain things in the organization. But you do need a baseline and a scaling unit, and if you are going into cloud with cost in mind, we need to get a common sort of metric. And there is a white paper on Gartner that does this with an algorithm that you can use in a spreadsheet you can download. We use it, we've played around with it over the years, and we've added some things and removed some things. But effectively, it sort of gives us a way of determining, based on what we've paid for things, FTE models, price per square foot of data center space, WAN links, you name it, everything in there where you input the variables of what you can. And it will give you sort of a scaling unit and a good idea of what that costs you currently on-prem to actually run that. And if I give you an example here, you know, IS server 284 quid. So if we take that baseline, we can actually get to this is just using an example, that this application costs £1,542 a month to run, split down like that, using some, you know, industry analyst methodology. You would then typically incorporate some form of disaster recovery. Well, the algorithm really, you can play around with this, but the algorithm really would have two for that. You've got the same amount of hardware. I appreciate that you may not have storage at the same performance, you may not have as many compute blades, you may not have the same resilience or M+1 at DR, but by the time you factor in the operational process to actually run that and maintain it, you know, the general consensus in the market that is, if you are providing DR for an application, it is times twice. It's actually a little bit more, so this is a bit conservative, because you've got WAN links and you've got all the other kind of maybe software that goes on top to make it replicate. So actually it's never usually times by 2, it's usually a little bit more in reality, if you're being honest about it. And then you would effectively make, a lot of organizations have got a test and dev stack, which again is the same. So if you just add that out, you're looking at a baseline at about 4,600. You could put a confidence rating in there. So you could actually say something along the lines of, you know, I might put a confidence rating of plus or minus 30%, so I might want to be quite aggressive with it. It might actually in real terms be less than 4,000, or it might be more than 5, but just as a baseline, you could be looking at $4,500 as total cost of ownership of that application to run on-prem. Now, when you compare that to cloud, pay as you go, if you would just spec that with the instances, you know, the VMs at the front, D12 standard instance, web front end 765, 595, you know, I don't need to go through it, but you're looking at around £3,745 there to run that in cloud. Now, instantly, you know, you're already, before you've even started, you know, you're not far off the same price. So is the business case there? Probably not. The fact is, when you optimize on the way in, we haven't actually, if you look at now the front end, this is using 4 smaller instances. It's exactly the same performance. It's using things that you'll get for free, things like load balancers that will cost you a fortune on-prem, but actually just come as part of a package in cloud. So not actually changing the compute power, but just literally making that stateless front end split across 4 smaller servers that can also scale up and down, as opposed to having 2 chunky servers like we had before. Automatically we're at 275 quid now, and in some cases we can actually utilize the free tier, so we can get some of the hours a month paid for as well. So, and that is quite common, you know, that is common. So instantly you've got a rejig of the application tier, and also bringing your own licensing. So now you're in a position where when people use the calculators online, they're the worst things you can use because they don't factor in any of your current licensing that you currently got, any of the hybrid use benefit that you may have, any of the deals that the cloud providers will put in place on licensing, and they do it, you know, if you're sort of doing a large-scale migration. But we can quite easily get that down to 1,430 a month, easily. And I'll keep going. So the next thing is we might add some replication software in. Now, you might be within the cloud provider, but just to make this a little bit less conservative, to just sort of prove a point, we're putting in some third-party software which will do in between cloud regions and cloud to cloud, AWS to Azure, Azure to Google, Google to AWS, AWS to Azure, whatever it might be, but some third-party software that will actually replicate the whole virtual machine instance into a different cloud. That's going to cost you for that application about £673 per month. And then if you add in the fact that you may be using 8 hours a day of test and dev, for example, you might be using it through the night, add the 476, you sort of get yourself to a price that's 4,600 comparable to 2,500 when you do it properly. That is common. And if you talk to anyone that's done a large-scale cloud migration, or you know, especially where you don't have to redevelop the app, and I'll come on to that in a minute, you know, you sort of seen that 30% TCO saving is becoming a common figure for people that have actually done it. And the people that are saying it's more expensive, and there's a few out there, the cloud refugees, that some of the hardware vendors like to hang on to and say, look, these people came back, it's not all. Typically, what we find, and this is our personal experience and my personal experience, is it's just been a lift and shift migration as is, with no optimization, done with a pay-as-you-go, you know, with calculator-based online calculators, and just literally lift the VM as is. And that's not really how you'd want to do it. But 30% from a lot of people out there who've done a full-scale migration is a common figure. And that's before you take into account everything else. So reserved instances, if you know that you're going to have that VM for between 1 and 3 years, we'll buy that down at the start. There's a capital included with that. Which for some organisations is actually a good thing. It allows you to capitalise some of that if that's how the budgets work. But reserved instances, 60% easily are certainly up to 3 years. Use times turning off when we start to, you know, you would never do this on-prem, but in the cloud up to 65%. Ongoing optimization, which is effectively new instances come out. Cloud providers get access to new types of instances and Intel CPUs before they go on the shelf with your hardware provider. So ongoing optimization of, you know, maybe another 40%. And there's a lot of times we can actually just take the databases and maybe put them into SQL Parse, Amazon RDS, whatever that may be. And you can actually get up to 80% savings there when you start to use functions and you start to use, you know, PaaS-based compute, and you can actually get out of the VM. So if we can get ourselves into a position where the application will lend itself to come out of the VM and into a PaaS service, which we see more and more of, you can get up to 80% savings there. So the 2,500 just keeps coming down. So it's sort of a bit of a myth that I want to debunk, really, that when you do it properly and you walk through all those different, so it's just not true, in my opinion, for the large scale of stuff. So the next one is cloud isn't secure. I actually think this is going now. Most of the, you know, you can actually search for the cloud provider and what accreditations it's got in each region, in each, you know, in each one of its services. And if you look at something like a Microsoft, have just taken this off, you know, and Amazon have got exactly the same. But, you know, and I took this the other day, Microsoft continues to invest over $1 billion a year on cybersecurity. You know, we did a survey that some people have spent less than 20 grand last year on cybersecurity for an enterprise business, which might have just been a firewall upgrade or something like that. So you can kind of see now that, yes, just like on-prem, if you leave firewall rules open and you've got bad operational practices on-prem, if you take that to cloud, of course, you're going to get exactly the same. No issue in any way, shape or form. But one thing you can sort of be certain of is that the actual infrastructure layer below the application is incredibly secure from the cloud providers, just due to the budgets that they have and the operational teams that they have on that. So the confidence is built in that now, and there's a hell of a lot of mission critical and defense applications that run in cloud. So I think that one is starting to go. The great thing about it as well, when you start moving into PaaS, is if you look at something like a WannaCry, something like that, when you start moving into PaaS where the OS is effectively offline, so there is an OS there that Microsoft manage, but for all intents and purposes, it can't be seen and it's offline. You're actually reducing the attack surface massively. If you can get yourself from having 400 operating systems, 1,000 operating systems that you've got to patch and look after every 6 months, and if you can get maybe even 25% of that into PaaS when you move, maybe not even that, you know, there's potentially 200 operating systems there, and every time you can do that, and every time you can modernize that app and use a PaaS service, you are reducing its attack surface. You are taking away some of the vulnerability of having to patch and look after an operating system. So in some ways, PaaS services, you know, are really good from a security perspective because it stops us having to look at that kind of thing. And when you look at cloud native application design, and we have a department now that does this, so we made an acquisition in December of a cloud native application architecture company. You know, you sort of remove a lot of the configuration-based vulnerabilities, some of the zero-day malware. You know, a lot of enterprises have got a lot of old systems that don't lend themselves very well to modern patching processes, modern antivirus, modern ways of doing things. And, you know, when the exploits are all in the new world, some of these traditional legacy apps, they're just not built for it. So cloud-native apps are just inherently more secure by design, and the fact that they're microserviced and you've got bulkhead designs in there, and you can effectively stop some of that vulnerability from spreading quite easily. So, you know, it's just one thing to think about. Cloud cannot host mission-critical apps. So I was a bit of an advocate of this about 4 or 5 years ago. And what I actually meant by that was, if you look at service levels of the cloud providers 4 or 5 years ago, it wasn't enough for an enterprise to really adopt. There had been outages that had been out for a while. The service level SLAs weren't that robust in comparison to what some people were maybe used to. And it was sort of only really for those organizations that were doing sort of consumer-based applications, that if it went offline I may be able not to download something or play my music or whatever that may be. But you've started to see that totally change now in terms of mission critical apps being hosted on Azure and Amazon Web Services. There's lots of case studies of incredible mission critical apps, and a lot of large scale enterprise organizations with some of their key apps are all running now in cloud. And if you look at just this Azure service uptime, I just took this one. There's Amazon as well. I just literally thought I was going in alphabetical order, but I took this off Cloud Harmony. But you can kind of take a look there at all the services that have got uptime, all the different regions. So that's sort of something now that's starting to filter out. The uptimes, the operational processes, and the confidence is there for organizations to host mission critical apps in hyperscale public clouds. And I remember 4 or 5 years ago, I was always be careful of that if you weren't doing cloud native application design. If you weren't a Netflix and you were just looking to take your SAP to cloud, you know, always be careful of service levels. And I'm always worried from an enterprise perspective, because I know that enterprise organizations typically buy on risk, cost and value, and sometimes it was just not enough for them to move it, but we're just not seeing that anymore. You also now are in a position where you can design much more for failure because of the tool chain you've got in public cloud. You know, you're designing things with ephemeral servers, making sure that they're not writing things to the C drive. You know, we can use containers quite a lot now, more though than you can think. We can get a lot of traditional applications to go into a container now, which again reduces attack surface, patching, operational capability, loosely coupled designs, eventual consistency databases, so maybe moving out of a relational database into something that's eventually consistent. We see a lot of that. You know, you look at, I think MongoDB is now the 3rd or 4th most used DB on the DB list, so that's overtaken things like MySQL. So you can kind of see people moving into some of those modern data structures with databases such as Mongo that are eventually consistent and not using your traditional ACID principles as something that helps with the designing for failure. And developers like to engage with some of those applications or some of those modern databases more than some of the traditional ones, but it's just something to think about. Cloud is for cloud native apps only. So it's another one that sort of 3 or 4 years ago, that's where I was at really, you had to be careful. But really now, we've got a lot of customers that are basically saying, we know that this application, if we just look at this application on its own, it will be dearer to run in cloud. It just will. But as a TCO of turning off a data center and getting into a new operating model and investing into a brand new operating model, actually it's worth moving this. It's worth just lift and shifting it as is and just running it as VMs natively with the provider in infrastructure as a service. And I'll give you an example of why you can get lots of benefits for that. So first off, cloud providers have got huge families of different types of instances optimized for different things, and you can actually find that you've got an application, or you've got an environment of an application that might be 10, 15 servers that will run better in a public cloud just purely because the instance is tuned and optimized on the right kind of hardware that maybe you wouldn't invest in on-prem with a different type of CPU. But actually at the same time, you can get, you know, instances with hundreds of thousands of I/O that will cost you a fortune on-prem to do that with SSD technology, but in cloud you can get that at a good cheap price point. So performance becomes more of a commodity in the cloud, and you can effectively change a lot more easily whether you really need. So what I'm basically saying here is that don't think it's just scale out cloud. Scale up has got a lot of options in cloud as well. And if you just lift and shift in a traditional hungry application to the cloud, you can actually find yourself that you're in a family of compute instances and storage types with options that you just couldn't get on-prem. So do not rule it out in any way, shape or form. There is no reason why they can't go to cloud. We've also got some customers who said, we're going to put this in cloud because we can actually integrate certain parts of the applications with things like search. So maybe people have been going, I'd like a search interface that allows me to search the database outside of the application. So just little bolt-ons to the application that just add more value to people that are using it, that are actually maybe quick fixes for somebody to get some information. You can do much more because of the tool chain you've got. You can actually take that application and start to build around it. So what you end up with is my tree where you've got the trunk, which is effectively the big monolith, and then you have branches peeling off, which just give you so much more creativity that you can do with that application without having to rebuild the whole thing. You can start to bolt things on the side, and cloud's really easy and quick to do that. You've obviously got the agile test environment. It's much easier to evolve the app, and it is quick to migrate. So sometimes, people can sort of sit there and go, we need to refactor and rebuild all our apps before they go in the cloud. It's just not necessarily true. Sometimes the business case might be based on speed and just getting stuff in there, and that's totally fine, absolutely fine as well. So don't be put off in any way, shape or form. Please perform a full assessment. All the cloud migrations that go wrong, I've been there, I've seen them. Haven't had a proper assessment done. They don't know the application DNA. They haven't done application portfolio management. There's no migration or true migration strategy. There's nobody actually looking sometimes from the app and saying, what are we doing with this application? And this is just things like doing a full APM, like a time analysis, and actually coming up with effectively what are the migration strategies. And we do adopt the Gartner one, which I'll just take you through, which is effectively 6 most common strategies: rehost, lift and shift, legacy migration, fast, designed to get rid of a compelling event. We don't want to renew this data center. We don't want to renew our hardware. We don't want to pay HP, EMC, NetApp, whatever that is, the money to just keep extending that. A replatform is maybe optimized during the migration. So effectively, tangible benefit, you might move the database into a database as a service. You might move certain bits to PaaS. You might change the licensing model. There's things there. You might reinstall it. You might upgrade the OS. Whatever you may do, there's a bit of a tinkering going on the way in. You might rebuy the app. So we've got customers now that are saying, if that app won't run in cloud properly, we need to find another app. It's as simple as that. I understand that in some organizations that can go down well, and it might not go down well, but there are people actually doing that, saying this is an old traditional horrible application that we just need to get off because it's too expensive, and there's other things out there on the market that we can use, and that might be adopting SaaS. It might be, we would always be SaaS first if you can, definitely, but definitely for your commodity applications without a doubt. Refactor is, maybe where your consolidation, so you might be knocking the application around. Now, getting a development team to take an old application and knock it around for cloud, good luck. Some developers just don't want to work on those kind of projects, to be honest with you. It's sometimes quicker and cheaper to rebuild it with modern development techniques and modern tooling. There's lots of low-code platforms out there as well that can get us an application that does what the old one did 20 years ago in a quarter of the time at, a third of the cost. So, but there are people that, if you've got your in-house development team that just to make some tweaks, absolutely refactoring. Retire. 10% of applications we look at when we do APM across the customer's environment and assessment aren't being used. At least 10, if not 15. They're just not being used, but they're sat there, no one's logged into them. So finding out what they are to get rid of them, and then obviously things retain. This might be, we're going to have to leave it for the minute. It is what it is. You might call it retain or revisit. It's one of those things that might have been recently installed, recently upgraded, and we've just got to do what makes business sense there. We might have to depreciate some hardware, we might have to just keep that application as it is, whatever that is, but you'll sort of see those are the different migration strategies. And then you end up with this thing, like it's called a time analysis effectively, where you've got tolerate, invest in, migrate, and eliminate. And it's not always about if applications can move to the cloud, but how they also should be moved, using the 6 R's as a principle of doing that. But it starts with app down, this is not VMs, it's applications, because it's fascinating when you actually go through it, what we can actually do. If you can adopt aggressively, do it. Some people say, I understand that that's risky, and I understand that people are scared off when I say that, and they say, but we're a risk-averse enterprise, I'd never get the business to do it. I get it, I totally do. What I'm basically saying here is if you can adopt aggressively, do it. The reason being is that riding 2 horses, it can be challenging for a time. So if you're in an environment where you've got half your app in cloud, half on-prem, when you've got long change windows and very risk averse, it can actually be riskier to approach it risk averse in that way. So it's just a different mindset thing, really, that if you can adopt aggressively, it will make the business case work out better. The cloud providers will always provide a better deal on licensing or any kind of agreement that they do, long-term agreement. Microsoft and Amazon do things when you're spending certain amounts of money. So obviously, you absolutely 100%, if you can show an aggressive adoption path, it will be cheaper. It just will. But try not to be in this state state for too long if you can help it with a particular application or something. You know, if we're going to move it, let's move it and let's get it done. And I think a lot of people that have given feedback on a cloud migration have said we should have just bitten the bullet and done it and not been like we were. And again, there's lots of people who are out there doing talks on how they've done it. Risk averse is great. I'm totally up for it, but just be careful of of not putting speed behind it and getting it done, because it can work out worse. And be careful of defaulting to hybrid. And the reason why I say that is everybody talks about hybrid, and I think if hybrid in terms of moving. I've got some SaaS applications, when you're delivering a SaaS, you don't really care where it comes from. So hybrid in that sense, yes, by default. I think the point that I'm trying to make really is, we have a lot of customers who say, well, the old stuff I run on-prem and the new stuff I run in cloud. And I would always challenge that and say, well, why have we got old stuff? One of the hardest issues in enterprise IT is running old systems, and the biggest bugbear of enterprise IT and why it can't sometimes move as fast as it'd like to in the economy we're in today is because it's got old systems. Of course it has. So when people sort of say, well, we'll leave the old stuff on-prem and the new stuff in cloud, I'm always a bit like, well, why are we not rebuilding the old stuff, and why are we actually, paying for operations to manage these traditional old systems where the vendors basically rip us off and like to tie us in and charge more and more each year for support and maintenance contracts? Why would we do that? There's a lot of organisations now that are debbing themselves out of the legacy fast, using modern development techniques, shrinking down their operational capability, building development capability, using lots of third parties, using lots of services that are out there to gain some speed to basically get them out of the legacy systems. And I know it's tough and I know it's not easy, but leaving them to rot on premise I don't think is the right way, because you've not got legacy old systems, you've got legacy old insecure systems. And I would always worry of old on-prem, new in cloud. I just would, and maybe it's a simplistic view, and I know that everyone's got an opinion on that, but when we put a survey out there, everyone goes, oh yeah, hybrid, and I'm just like, what, why? And there's not always a good, I'm going to use 2 cloud providers is another one, and it's why. There's arguments for in each. I'm sure there's niche use cases, but just be very careful of just using the market rhetoric of hybrid. It's not always your friend. And you've also got the cost of the final server, because one server means you've still got a massive core network with lots of switch ports, with lots of things plugging into each other, lots of complexity, and you've maybe got 5% of your server estate on-prem, but you've still got all the cost of the surrounding ecosystem, the operational tooling, the support contracts, everything around it. So just be mindful of how much the cost of that final server actually is. It's not the cost of the server, it's all the surrounding bits that you need to do that, firewalls, you name it, everything else. Cloud means no operations. This is the biggest myth of the lot, really. Ops just changes. So you might hear people talk about no ops. Now, ops, and that is typically what you'll find is where operations is taken care of by a development department, which inherently makes it DevOps. But what you will find is there are what you might call some elite in the industry, developers that do operations as well and do it very well. And effectively, you wouldn't need 2 functions or 2 people to even do that. And you'll hear your Netflixes and your WhatsApps of the world and your Facebooks of the world talk about, well, you're in a position there where you're hiring some of the most, some of the best in the world that might then turn around and go, we don't have ops, I think it just happens. Now, developers typically don't like to do operations, and it's not particularly productive for them to do operations, but I think that a lot of operations teams feel that, when they've been working in traditional infrastructure and traditional I&O teams, that, the cloud providers take all that away, and they don't. Ops gets much more interesting, actually, and it's a completely different role, because it really starts to add value in areas like speed, especially when you start to use function-based compute to do certain things. But the problem with cloud, and it's a problem and it's a good thing and it's a problem, is that everything's on demand. And when you get into cloud first, you start using VMs and some storage services and some basic infrastructure services, and before you know it, you are consuming some of the higher order services that offer lots and lots of business value. And from that perspective, it can get, if that's ungoverned, it can get expensive. So what you really find where operations starts to focus on is how you sort of get governance, and how do you do governance as code? How do you create standards and consistency? How do you give the people to freedom? How do you actually adopt that cloud culture and that cloud operational model where people can consume, but they can consume it safe with cost controls in a secure environment? And a lot of what we do in cloud is this. This is really what our support organisation in our business does. We're there making sure that we're supporting organisations, that there's frameworks in place, there's governance frameworks frameworks in place. There's code in there, there's trip switches, there's fuses, there's things that stop things from happening, there's things that stop people from spending too much, permanent right sizing. You're always trimming, and it's a permanent loop operations in cloud. It's a little bit different because it changes and it does involve some new skill sets. Like, it's really helpful in operations in cloud if you can perform some scripting and you can code. Because there's nothing to stop you just using the standard tooling, but what you can do in ops, if you can code yourselves around all sorts of brilliant, problems, or all sorts of different operational circumstances that you might get yourself into. But this notion of no ops, it doesn't exist. A&S has got a business that runs on ops in the cloud. So as far as I'm concerned, that is just not true. It just changes. Where that ops happens, is something else. But operations definitely exist, and the organisations that go low ops spend absolutely stupid amounts of money and have loads of security holes. So it's just not true. And I'll give you an example of cloud governance. This has come out of one of our pieces of tooling. So this is a customer that we were working with. So if you kind of look, started the cloud adoption there, $10,000. This is dollars, $10,000 a month, ramping up, and you can see they're migrating systems in. And they're doing it at pace. So between December and February, we've gone from 10 grand a month to 40 grand a month. A few more systems go in, 50 grand a month. And the different colours are the different services that are being consumed in the cloud. So, blue is typically compute, red might be storage, turquoise will be a database service. So that's how it sort of breaks down. And you can see them ramping up all the way to August, where the bill's nearly $70,000 a month. And at that point, there was no real optimization or operational optimization taking place. It was a fast shift into cloud by this customer. And then at that point then, we started an optimization program of work. So this was A&S's service, and I suppose there's a little bit of a plug here. It's not designed to be a sales plug, but just to give you an idea of what good ops looks like. We started to trim that all back, use the tooling properly, refactor, move some things into PaaS, certain areas where we can use cheaper services, turning things off, usage times, powering down test and dev, lots and lots of automation. Before we know it, a year on from a bill that started at 10,000, we've got the full environment, it's got up to 70,000 a month, and then we're back to just over 20k a month in November 2016 there, and the idea is then can we keep it there or can we make it cheaper? So you can kind of see that the people who sit out there migrate in and it gets to $70,000 a month and they go, oh my God, cloud's the most expensive thing in the world. This is, I assure you, this is completely live from our billing tooling, with the same estate running at the same performance levels, with the same VMs, with the same applications, with the same storage, with the same DNA, literally with an operational model that's designed around efficiency to chop 50 grand a month out of that bill. That happens. When people don't do that, that's when cloud gets expensive. And there's a lot of that out there. There's a lot of people that hit the $70,000, $80,000 a month mark and then start worrying and start thinking, well, and then the adoption slows down. So governance is key. So I would always use a CSP service to keep it automated and efficient. I'd always have a wide pool. Amazon and Microsoft Azure skills are tough to find, tough to find at a good price point. They are. There's a range of people like ourselves and others out there that offer those skills as a service a month. So you can call on, access to a really wide technical pool. We've got over, I think, 30 certified engineers in Azure and Amazon Web Services. It's a really big area for us. So don't fear, it's not a traditional outsource or a managed service. It is an extension to your team. It is people that understand some of the service, how to use and consume them, and people that are good with governance and we've got a lot of code and a lot of operational procedures that are cross-customer that we can use. So lots of economies of scale there. But the other thing I would always worry is when you advertise for a cloud engineer and people put AWS engineer wanted, Azure engineer wanted, the challenge that you have with that is there's 280 odd services in Amazon. People make a living just knowing 5 of them. So when you're sort of saying, I want an Amazon engineer or an Azure engineer, a lot of people now say, well, which bit? Which bit of Amazon and Azure is it? Because you've got people that are specialists in the BI functions, people in machine learning, people in just general platform, people in some of the development capabilities. So just to advertise for one, a lot of questions are being asked now to say there's that much in here. One engineer, so we have different disciplines internally, so we've got different customers using different services. We've got a way that we can scale it because one person just couldn't physically keep up from a training perspective with what's going on. So just be very mindful of saying, I'm going to employ an Amazon engineer. They're not, not only not easy to find, but what exactly is it that you're using in there and what your applications require. So some key takeaways really: find the right mindset, design for efficiency, always assess your apps. App DNA is absolutely everything. Develop the right roadmap and do that in tandem with someone that's done it before. Don't just buy some tooling that just throws VMs in there. It's a terrible idea. That is the riskiest, most the most expensive way you can physically do it, and make sure you invest in the right operational capability. If this is on-prem, it could be potentially, it could be expensive to do that, or to use a CSP maybe that can give you access to a really wide technical pool of people who use all those services on a daily basis. So it's just a key takeaway there. So on to the Q&A. So we've got a couple of minutes there to answer some Q&A, and I'll just look at Charlotte. Do we have any questions there? Yeah, we've got a question. Great. Okay, just give us one sec while we pull those up. Okay, how do you maintain the cost model? So, question from Stephen. How do you maintain the cost model with this new instance costing? Is this automatic or manual? So, the first thing I'd say is, how do you maintain the cost model with it? Right, so new instance costing, right. There's two ways of doing it. There is tooling out there on the market that will make recommendations based on a usage profile. And I hope I'm answering your question properly here, but I'll go down this road. And if not, we can have a private chat about it later. But there is tooling that will effectively, it's like monitoring tooling, but it isn't really monitoring for uptime, it's monitoring for cost. And what it effectively does is it will make recommendations on certain things in real time. So maybe it says, and it will make a recommendation on maybe the type of license it should have, the recommendation on the type of instance it should be sat on. It will make recommendations of when you should turn it off because it's not seeing the usage. So you do start to build a DNA, and there is tooling out there that does that. We use a tool that does it. It's about 50 to 60% accurate. It always needs to then go through CAB, or with fast CAB, if you will, in sort of the cloud world, that basically makes it, is it true? Because sometimes it will get it wrong with things like, it might recommend to move one instance to another, but the disk type that you're using that the data's on isn't supported with the other instance type that it recommends. So you kind of need a bit of human intervention there, but what it does do is do a good first pass for you and give you a good idea. But it's a mixture of automatic and manual. And there is, like I say, there's tools out there that can help you do that. So next one, when you reference reserved instances, I presume for dead QA systems, reserved instances may not work for some companies as you reserve the instance for 1 year or a period of time. However, you may only actually use it for 8 hours a day. Do you see your customers only using reserved instances for production systems? Yes and no. You've now got flexible reserved instances, which means that you can use them much more for dev and test, but majority of use cases are reserved instances on production systems. Just to be clear, reserved instances aren't always the cheapest way to do it if you've got a high change rate environment. So people automatically think, I need to buy a reserved instance for that. Actually, usage times and automation for power on and power off might be cheaper than an RI, even though you're paying a full fat pay-as-you-go. So again, it's something that you help with tooling and knowledge about what is the right way. And I think that some people automatically want to default to a reserved instance because it is a lot cheaper, sometimes 40, 60, 70% cheaper. But depending on its use case, depends on whether that's actually a good idea. And we've had customers that have bought down reserved instances that are just not getting used. Now, what you can do with a CSP, certainly like ANS, if we resell the Amazon or the Azure, we can actually almost take that instance back off you and reuse it somewhere else. So what that basically means is then you get access to a pool of instances that might be right through a CSP like us. But yes, you're right, the default is that long-term static production systems are better for our eyes, and on dev and test it depends on the profile of whether that's the right thing. So, next one from John. What about the benefits of needing less rare, expensive technical staff in the cloud? Okay, so I would argue that it depends on what you're doing in cloud. So if you just pop that question back up, Charlotte, please, thank you. Yeah. So what about the benefits of So if you are looking, at the minute, it's an engineer's market for cloud skills. And this is from our personal expertise because we've got about 30 cloud engineers. It's the hardest thing to recruit for, I believe. So a good, strong, anybody can put VMs in the cloud, but cloud native application architecture and cloud engineering, it's an incredibly competitive market. You've got a lot of startups out there that are offering, pre-IPO share packages and equities in business. And, there's lots of startups certainly around the city and in Manchester that are offering good packages in that way, shape or form. And a straight up Amazon engineer anyway, there's a lot of them want to contract. If I'm honest with you, because it's a contractor's market, there's lots of really innovative projects going out there, and some of them are asking for high salaries, and the market is dictating that. So if you are looking at Amazon and Azure engineering, I'm not saying you can't find them. What I'm saying is the rarer than finding in your traditional I&O, your VMware and storage sort of staff, they are harder. We have job adverts out all the time. We train some ourselves. We have an apprentice academy that does that, which allows us to just pick up the training internally, and we've also recruited externally to get in some experience. And then we've also had some engineers that have moved from what they were doing into the cloud world because they've got the skills that are adaptable and change. So in terms of the benefits, if you can get, less raw or, technical staff, great. But if you're moving things to SaaS, then definitely that negates the need. So without a doubt, if you're basically saying that you can get the majority of your applications into SaaS applications, then yes, you will not need the level of technical requirements, in my opinion, that you would have needed before. Or you'll need slightly different. You'll need service transition managers, service managers, whatever that may be. If you're a large enterprise that's got a lot of operations and you've got a lot of custom systems and a lot of hot software and a lot of things that can't be SaaS'd, you're going to need some AWS and Azure expertise if you are looking at one of those two cloud platforms, and you're going to need to really call on a wider technical pool, on a cloud specialist that can do that, unless you can pay the money to recruit them and get those in-house. So I hope I've answered that question right, but if you're looking at, to just summarise what I really mean there, you definitely, if you're SaaSing, without a doubt you don't need them, but if you've got lots of traditional and bespoke applications, then you're going to need cloud engineering expertise. So it's a mix of two, and it depends on your app profile. We have some customers that can SaaS 60 to 70% of what they've got, and we have some customers that literally, I was with a customer I remember it was a central government customer actually about a year ago, and they have 489 or 498 apps, one or the other, and they couldn't SaaS any of them. There was just a 30-year heritage of stuff. It just wouldn't SaaS well. There was nothing out there on the market that matched it. It was literally a consolidation exercise and a redevelopment exercise. So you've got two very different types of business there. It just depends on the application landscape. It really does. All great questions, so thanks very much for that. We've got one more. Oh, do you see the cloud architect role as necessary within a cloud transformation exercise? Yes, 100%, definitely. Yes, couldn't agree more. The cloud architecture role is the key role, and I'll tell you for why. Because if the architecture is wrong, you'll lift and shift what you've got. And if you've just got traditional engineers that think in VMs, and it is a mindset thing, and maybe I'm being a bit harsh, I don't know, but there's a mindset around the VM of VMs. We're trying to get away from VMs. VMs are, things that effectively, everything revolves around the VM. It's got an operating system, it's got its VMDK, it's got all its different attributes and its configuration file and everything. And there's a set of operational procedures with a VM. The operational procedures shift in cloud, and only really cloud architects know that. And I think that if you sort of met some of our cloud architects and the sort of people, and certainly some of the younger crowd in A&S that are getting into cloud architecture, they don't really know the old world. So some of them don't really sort of understand why we used to do things like that. And the ones that the challenges that we sometimes have is when you haven't got true cloud architecture is not like VMware architecture or Hyper-V architecture. There's so many services out there, we can break the application up. We can probably design one application and platform it in the cloud 10 different ways. Option 1 will be 10 grand a month, option 2 might be 300 quid a month, option 3 might auto-scale, option 4 might use a service that we've never used before, option 5 might put the database into PaaS, option 6 might be geo-replicated, non-geo-replicated. Option 7 might be failing Amazon to Azure. All these different things in cloud architecture it's such a key part of a cloud transformational process. And that cloud competency center and building that internally yourself to understand some of those operational capabilities is absolutely key. And obviously, if you can use somebody or somebody can help you with that cloud architecture role, then obviously that's a service that the market is offering at the minute, including A&S. So it's absolutely necessary. The engineering is a little bit easier because the cloud architecture is, they're giving them the plan to sort of design to. But just things like building cloud formation templates, ARM templates, infrastructure as code, and how the governance works with infrastructure as code, it's very difficult to on-prem, and only a true cloud architect can really get the best out of that. So that is my opinion. But yes, is my answer there. And I think, is Cloud Competence Center the same as Cloud Center of Excellence? Gartner talk there saying, yes, it is. For all intents and purposes, yeah. I'm sure our enterprise architect Chris Mills and the guys there, Peter and Martin, might have some nuances or differences between the two, but as far as I'm concerned, it is a little bit of Cloud Competence Center as Cloud Center of Excellence. It's basically building a team. It's very difficult to get infrastructure and operations people who have got a day job to learn new world. What we did at A&S is we built a new department. And we built that new department and we spun that out and we moved people into it. So we made sure we tried to get the culture right, the tooling was different, the operational processes were different, the way we engage with the customers a little bit different. And trying to ask people who have got a day job running infrastructure and operations to then try and learn cloud operations and the cloud world can be quite difficult, and they might do it, but it might take too long for them to become competent or whatever. So actually, it is an investment potentially in either a third party to help you with it, or some people that internally are virtually responsible for building that cloud competency, for understanding cloud terminology, understanding cloud architecture design, service levels, everything that's involved with cloud. Yes, to answer your question, I do talk quite a bit sometimes, sorry about that, but to answer your question, yeah, it's Gartner's, but it's the same. We use a lot of Gartner methodology as well, so yeah, I imagine it's the same. Let's give it 10 more seconds, see if anybody's got anything else. Nope. Well, thanks very much, everybody. I hope there was some nuggets in there. If you took 2 or 3 things away from that, then I hope it was worth your while. I hope it was spending an hour. Please give us feedback if you've got any feedback on it. But I'd love to. Obviously, some of the people I know on the call I'm looking at, and some people I haven't. So if I get the opportunity to meet you, great. Have a great day. Thanks very much, and I hope you join us on the next one. Thank you. Bye bye.